This lecture will focus on sections 6.1 and 6.2. And in 6.1 we'll start off with ratios. Let me tell you what that is. A ratio is a comparison of two items. Well, I should say two items, probably two quantities, because we're going to be talking about numerical values. Two quantities with the same units. So let me give you some examples of things that you might see. Let's say, well, you might see something like this: $10 to $30. Or I might write $10 full colon $30. So these mean the same thing. And the version that we'll be using most often is this one. $10 divided by $30. All three of these things are the same thing. So with that in mind, we're probably going to focus most of our energies on these fractions because we'll be able to do something with them. For example, if I take the $10 and divide it by the $30, I can treat the dollar sign just like it's the units, because it is the units. This top says $10 even though they put the symbol before it. So I can cancel the dollar signs and I'm left with 10 over 30. And of course you can simplify this to be 1/3. So this would be the simplified version of that particular ratio. So the units, when I say the units are the same, I'm talking about exactly like what happened here. I was able to cancel them away. Let's do some examples. Most of these, what you're going to have is I'm going to give you a ratio, and then I want you to convert it to a fraction in lowest terms. So convert to a fraction in lowest terms. And what I give you here is 4/3 to 6 over 25. So for that one, I would treat it this way: 4/3 divided by 6 over 25. And then this is a ratio as like the last example. But you know, when you divide fractions, you multiply by the reciprocal of the bottom fraction. Like so. And then can I do any canceling? There's not going to be a lot, but I can cancel a 2 into the 4 and into the 6. So it looks like my simplified version here will be 50 over 9, or 50 to 9 if you prefer that kind of description. Another example. Let's write, for all these, most of these are going to be exactly the same thing. So write as a fraction in lowest terms. And what do we have? We have 8 ounces to 12 ounces. So this converts to 8 OZ divided by 12 OZ. And as you might have guessed, I'm going to cancel the ounces out. So that leaves me with 8 over 12. Now, is that fraction in lowest terms? I hope you can see that it's not. I can cancel a 4 into the 8 and a 4 into the 12. And I end up with just 2/3. Same thing, write as a fraction in lowest terms. This time we have 300 miles to 450 miles. And let's see what this turns out to be. So I have 300 mi divided by 450 mi. I can cancel out the miles. And while I'm here, I guess I'm going to do a little simplifying also. For me, the quickest thing that I see that cancels out is 10 goes in the top 30 times and 10 goes into the bottom 45 times. So we have 30 over 45. And that's not as simple as it gets, though. I can go more. Notice that 15 goes into 30 and 15 goes into 45. In fact, 15 goes into 30 twice, and 15 goes into 45 3 times. So as with the last example, we end up with 2/3 again. Another example. Suppose I have 6.2 million to 100 million. Same deal. I want to write it as a fraction in lowest form. So let me start first with the fraction part of it. All right, cancel the millions away, and we get 6.2 over 100. This is not considered in lowest terms. It's not even considered, I guess you'd call it a proper fraction, but nonetheless, it's nowhere near in simple terms. What you can do to fix this is I could multiply the top by 10, but I have to do the same thing to the bottom. The purpose of that was to change the top to a whole number. I could move the decimal place to the right 1 unit by multiplying by 10. The bottom then becomes 1,000. And there's not a lot of simplifying here other than 2 goes into 6231 times, and 2 goes into 1,500 times. So we simply get 31 over 500. You'll not be able to go any simpler than that because 31 is a prime number, so you won't be able to cancel anything into it. Now, for some complication, of course, they're not all that straightforward. Check this one out. Here we have 36 minutes to 4 hours. Now, the units are the same if I change the 4 hours to minutes or if I change the minutes to hours. So, either way, I could do that. I think the easiest thing to do is to take 4 hours and change it to minutes. So each hour has 60 minutes. So we get 240 minutes. And this way I can compare things with the same unit. So I'll have 36 minutes divided by 4 hours. That's the same thing as 36 minutes divided by 240 minutes. And so I can cancel my minutes away. Between the 36 and the 240, I'm not sure what I want to cancel. I think I can cancel out, let's start with a 6. So 36 divided by 6 is 6. 240 divided by 6 is 40. So I'll have 6 over 40. Not quite as simple as it can get. I can still cancel a 2 into the 6 and the 40 and end up with my final answer of 3/10. Next one we have 16 quarts to 4 gallons. And you may or may not know this, but each gallon is 4 quarts. So 4 gallons equals 4 times 4 quarts, for a total of 16 quarts. Usually they don't write the S on here. I don't know why I did, but usually just QT is good enough. And so we're going to be doing 16 QT divided by, well, no. Oh yeah, that's 16 4 gallons. That'll be 16 QT divided by 16 QT, and everything cancels here, and you just get 1. Last example, these 6.2 is really where we're heading with these things. This is just to warm you up. Here we have $400 to $450. So I'll take my $400 divided by $450. I'll cancel the dollars out like I did before. I get 400 over 450. Now, when breaking this down, you can try to come up with a number that goes into both of them, the biggest one you can think of if you can. If you can't, you could do it in little pieces. So, like right now, I see that 10 goes into both the numerator and the denominator quite easily. So I'll have 40 over 45 when I've done that simplification. Now I see that 5 goes into the numerator 8 times, and 5 goes into the denominator 9 times, and we end up with just 8 over 9. And so this gives you an idea of how to work these ratios. We're going to take it a step further with the next section, and that is rates. So a rate is a comparison of two quantities with different units. So as an example, you might see something like this. A Prius can drive 600 miles on 12 gallons. So what is its, how many miles to the gallon does it get? I should say per gallon. That's better. So usually when people are buying a car, especially a car where gas mileage is important to them, they're usually looking for the gas mileage listed on the sticker somewhere to tell them, so that they can compare two cars to determine which one they want better. But for us, we have 600 miles per 12 gallons. So there's a rate. Notice I used a specific word, 600 miles per. That's the key word, 12 gallons. Anytime you see something, you see the word per, you know you're dealing with a rate. So anyways, to simplify, I can't cancel the miles or the gallon. They're going to be there for the rest of the problem. But I can cancel the 12 into 600. In fact, 12 goes into 12 once, and 12 goes into 600 50 times. So we end up with 50 miles divided by 1 gallon. And we'll simply write this, 50 miles per gallon. And in fact, this guy right here is called a unit rate. That's when the denominator has a numerical value of 1. I don't know how to say this. I don't want to say, I'll just say it has 1. I don't know if I can think of anything better. When you get to the denominator of 1, you know you have a unit rate. So let's take a look at some examples here to indicate some of these unit rates. Unit rates are everywhere. In fact, when you go to the store to shop, you almost certainly see unit rates. For example, you might see, let me just write some examples. You might see something like $5.99 per pound. So you might see something like that as far as, I don't know, maybe you're shopping in the meat department or lunch meat or whatever, and it lists prices as per pound. Or gasoline right now is currently at $1.65 per gallon. That's per 1 gallon. So I'll just write these over here off to the side so you can see that they're unit rates. That's $5.99 per 1 pound. And the other one is $1.65 per 1 gallon. So that's easier to see why they call it a unit rate, because that bottom is a unit. Let's take a look at, maybe you see something like this. Buying, I don't know, beans or something. You might see the price per can listed, or you might see the price per ounce, or whatever. You get the idea. These are some of the things we're going to be shooting for in our unit rates. They're useful in that they're easy to compare when you see multiple versions. Let me do the next example and I'll show you what I mean. Let's take a look at Miracle Whip. If you've ever looked for Miracle Whip or mayonnaise, it doesn't really matter. You know that it doesn't come in just one jar. It comes in various sizes, and typically what you'd want to do, if you could swing it, you would want to buy the size that is the cheapest unit price. So let me show you what we have. We have 10 ounces for $2.99. And then we have 24 ounces for $6.39. Which of these is the better deal? And to determine this, we will look at the unit price. So we want to determine the unit price So let's start with the first one. I'm going to do 2.99 divided by 10 OZ. Now whenever you divide by 10, you can simply move the decimal to the left one place. So it's like that, divided by 1 OZ. And so we would simply write 0.299 per ounce. Usually in the grocery store, they will go to 3 decimal places. But if you're asked to round to 2 decimal places, you would have this. if I were rounding it to 2 decimal places, the 9 here would force this 9 to go to a 0 and change that 2 to a 3. So we'd have 30 cents per ounce. This is round to 2 places. Now let's take a look at the other one. The other one was $6.39 for 24 ounces. So nothing's really quite simple here as it was last time. I'm not dividing by a power of 10 or something with a lot of zeros. For this, I'm stuck with doing the long division. So I'm going to have to do 24 into 6.39. Now what I'll ultimately end up doing is rounding my answer to 2 decimal places because, well, we're talking in dollars and cents. Even though I noticed that when I'm at the grocery store, they do go to a full 3 decimal places. But let's go ahead with this. Let me bring my decimal up, and I'll start with 24. It goes into 63 twice. So then I have 48. Subtract, I get 159. Now 24 goes into 159. I think it's 6 times. So I get 144. And then 15, and I can bring down a 0 if I want to go to 3 decimal places, which I do, because then it allows me to round to 2 places. So I got a 6 again that goes into here. That's good enough. So I have 0.266 per ounce. And we can already see which one's the better deal. The larger size is the better deal. But if I were rounding to 2 decimal places, so the rounded version that I want is 0.27 per ounce. So the better deal then is the one that produces the lower unit rate. This guy right here. And so the better deal is $6.39 for 24 ounces. Let's try another one. Which is the best deal for diapers? And here's what we have. We have the number of diapers and then their price. Let me go ahead and put these things in. We got 31 diapers, costs $10.99. Then we have 96 diapers, costs $31.99. And then we have 132 diapers, costs $41.99. So which of these is the best deal? So the first one here, that's going to be 10.99 divided by 31 diapers. The next one will be $31.99 divided by 96 diapers. And the last one will be $41.99 divided by 132 diapers. Now to convert to the unit price for each of these, I'm going to have to do long division. So let's start with 10. I don't know why I chose 10. 31 into 10.99. So we'll call this 1, 2, and 3. So I'm doing part 1. 31 into 10.99. So let's find out what we got. 31 does not go into 1 or 10, but it goes into 109 3 times. And I'll end up with 93. Subtract, I get 1, 6, and I can bring down the 9. 31 goes into 169 5 times. 5 times 31 is 155. And then I like to go one more decimal to ensure that I get 2 decimal places. What I get then is 1, 4, and I can bring down a 0. 31 goes into 140 4 times. And I end up with 124 with a remainder of 16. This is good enough. This tells me it's 0.354 per diaper, but rounded, I'm going to go 35 cents per diaper. That was option number 1. Option number 2, then, we had 96 diapers for $31.99. So 96 into 31.99. So 96 does not go into 31, but it will go into 319, and I believe it will do so 3 times. Let me see. 3 times 96 will be 270 plus 18 will be 288. And when I subtract, I get 31, and I can bring down a 9. Well, that's amazing. It's exactly the same thing again. I can multiply again by 3, and I get 288, and I end up with 31. This time I don't get a 9 after it. I can bring down a 0, and 96 goes into 310 3 times again. And this time I'm left with a remainder of 22. So this price is 0.333 per diaper, or rounded to 2 decimal places, 0.33 per diaper. And now for option number 3, we had 132 diapers for $41.99. So 132 for $41.99. And let's see, it does not go into 41, but it does go into 419, and I believe it goes in 3 times. Let's see, 3 times 132 is 396. And when I subtract, I get 19, I get 23. And 132 goes into that just once. And when I subtract, I get 107. I'll bring down a 0. And 132 goes into that 8 times. Let's see here. Let me guess at an 8, and I'll tell you in a minute. When I do 8 times 132, I'll get 800 plus 240 will be 1,040. Plus 16 will be 1,056. And then go from there. But I have enough digits. So 0.318 per diaper. Rounding to 2 decimal places, we have 0.32 per diaper. So, which was the best deal? Well, let me look at my unit prices. I have 32 cents for this last one. I have 33 cents for the one before it. And I have 35 cents for the one before that. So, the best deal is the 32 cents per diaper. So the best deal is 132 diapers for $41.99. Now I should warn you, it's not always the case that the biggest quantity is always the cheapest. Although it usually is, it's not always the case. Sometimes they do run weird specials, and you have to be on your game to determine if they have made the largest size the cheapest one or not. Let's take a look at another one. We have a 4-pack of batteries. Costs $4.99. A 6-pack of the same batteries sells for $7.39, which is the better deal. So what we have is $4.99 for 4 batteries, versus $7.39 for 6 batteries. Let's do the unit prices for each of these. So for the 4-pack, I'm going to have 4 into 4.99. 4 goes into 4 once. 4 minus 4 is 0. I bring down a 9. Bring down another 9. 4 goes into 19 4 times. I bring down, if I want to go one more decimal place, and I do, I'll bring down a 0. So for this one, underneath of it is where I'm going to put it. I have $1.25 per battery. Now over here, I'm going to do 6 into 7.39. 6 goes into 7 one time. Bring down the 3. 6 goes into 13 twice. 16 goes into 19 3 times. Now, for the purpose of this problem, you could quit right now, because right now I can see that the 6-pack is the cheaper one, because that 3 that I just got is less than the 4 that was in the same place for the other one. Nonetheless, let me go one more place. If I bring down a 0, 6 goes into 10 one time, and if I round to 2 decimal places, I get $1.23 per battery. So over here is the better deal. And when you get the homework, you'll see that you have several problems that are similar to these problems that I'm doing just now. Now, so those are the unit rates, they're the unit prices, I should say. Those are the things that you'll want to be using when you go to the grocery store, because most people do like to bargain shop, unless you have a preference for one particular item over another. So notice that all these talked about the same item. It was just whether you're getting more or less of a quantity that mattered. So let me do some other types of rates. So we can do, let's try a hot rod travels 500 miles in 2 hours. So to get a rate on this thing, I'll get the rate, I'll do 500 miles divided by 2 hours. So that gives me a rate. If I wanted to simplify it, then I could divide by 2 and divide by 2, and I'll get 250 miles per hour. So this version here is the unit rate. This other version of it here is just a rate that was unsimplified. Most of the times you'll be asked to simplify. Even you may not always be asked to put a unit rate in, but you'll usually be asked to simplify. So let me do another example. Here, let's do 150 feet in 20 seconds. So let's start with my basic general rate. I have 150 feet divided by 20 seconds. Now I can give a simplified version of this. Notice the 10 goes into both of these numbers really quickly. So I get 15 feet over 2 seconds. And so this is a simplified rate. Should I want a unit rate? If I want a unit rate, I must divide. You have to divide until you get a 1 in the denominator. So to do that, I'm going to have to go to decimals. So I'll put my 2 feet out front, or 2 seconds out front, and the 15 feet inside. 2 goes into 15 7 times, and I could subtract, and I get 1. 2 does not go into 1, but if I go to decimals and put a 0 after that, I can bring down the 0. 2 goes into 10 5 times. So my unit rate then will be 7.5 feet per second. So that's the unit rate. You'll usually be asked to find that or this one here, the simplified rate or the unit rate. It just depends on the nature of the question. Next one, let's do 10 cups for 6 servings. So let me do my rate. Simply 10 cups divided by 6 servings. And best you can do is to divide out a 2. I'll get 5 over 3. So I get 5 cups for 3 servings. This is just a plain old rate. If I want to do the unit rate, this is where I will have to do long division. 3 goes into 5 one time with the remainder of 2. Now you could write a unit fraction if you wanted to in a mixed number. Here, this is 3 1/2 cups. Do I want to say that? I did not. I said that completely wrong. Sorry. This is 1 2/3 cups per serving. But if I wanted to go decimal for this problem, what would I do? I would put a period after the 5, bring it up, and then put a 0. Bring down the 0. 3 goes into 26 times. I can bring down a 0. 3 goes into 26 times. And you can see this is going to go on forever and ever. So I could, instead, I could go 1.6 with a bar over it, cups per serving. So any of these would be adequate for the unit rate. Remember, this is what I'm finding here. The unit rate rounded to the nearest hundredth is, and for this, we're going to be looking at the 1.6, just enough of these until I can determine the decimal that I want. The hundredths spot is in the 6 that I just circled. The 6 after it tells us to round up. So the rounded up version is 1.67 cups per serving. So you'll decide, depending on the problem, depending on what kind of problem is, how you'll want to simplify and in what version you'll want to leave your answer. Here's another example. This is one you may have done it before in the past, but suppose you were paid $305.25 for 16.5 hours. Then if we look at the rate, we get 305.25 divided by 16.5 hour. Now this if you're asked to give just a rate, that is the answer. However, if you want to give it as a simplified fraction, this is what you have to do. I will have to get rid of the decimals in the numerator, I am going to have to move the decimal to the right 2 places. So I'll multiply by 100, and whatever you do up in the numerator, you have to do in the denominator. So I'll take my 16.5 HR and I'll also multiply it by 100. So this gives us 30525 divided by 1650 hours. So there's probably the rate that they're going to be looking for if they ask you just to find a rate. Now for the simplified rate. All right, for the simplified rate, I just want to simplify this as a fraction. So we're going to start with the 30525 divided by 1650 hours. So I'll just write HR. I don't know why I put an S at the end of it. Nobody ever does that. So let's see what goes into what. I want to do 5. I know that 5 goes into both the numerator and denominator. So let me check. 5 into 30525. 5 goes into 30 6 times. And then I can bring down a 5. 5 goes into 5 once. And so I can bring down a 2. 5 goes into 2 0 times. Then I bring down the 5. Good. So in the numerator, I'll have 6105, and 5 goes into the 1650. 5 goes into 16 3 times. 5 goes into 15 3 times. And hopefully you remember when you end up with zeros all there, but you still have another digit to put in. That's 330. So 330HR. Let me simplify again. I can, well, 5 goes into both of these again. So let me go 5 into 6105. 5 goes into 6 once. 5 goes into 11 twice. 5 goes into 10 twice. Bring down the 5, and 5 goes into 5 one time. So it looks like we have 1221 divided by, now 5 goes into 330 66 times. Now I want to see if I can simplify any further. Now 66 is 6 times 11. The numbers that go into it are 2, 3, and 11. That's completely all the numbers that go into 66. Do any of those numbers go into 1221? Well, I know 2 is not going to go into it. I don't know about 11. I don't want to even try 11. But 3, if you add up the digits, 1 plus 2 is 3, plus 3 is 6, plus 2 is 5, plus 1 more is 6. Since 3 goes into that, 3 will go into 1221. So let me go 3 into 1221. 3 goes into 12 4 times, and I'll bring down the 2. 3 does not go into 2, so since it was brought down, I have to put a 0 there. Bring down the 1, and 3 goes into 21 7 times. So I'm left with 407. In the denominator, 3 goes into 66 22 times. All right, now the only thing, now 2 does not go into 407. I don't know if 11 does or not, so let's try it. 11 goes into 41 time, 33. And 40 minus 33 is, oh, look at this, it goes in. Okay, so 11 goes into 77 17 times. So it looks like what we're going to have then is 17 divided by 2. I see where I made mistakes. Okay, there it is, right there. So that was actually 37 over 2. And that's as simple as you're going to get. Put my HR in here as the simplified version because 2 doesn't go into 37. But if I wanted a unit rate, I would have to take my 37 over 2 and do long division until it's done. So I would have 2 goes into 37. It'll go in to 3 once. It goes into 17 8 times. Put my decimal so I can bring down a 0. 2 goes into 10 5 times. And it turns out to be exactly 18.5. Of course, you never say to somebody $18.5. You usually say $18.50. So something like that is what you're going to want to put instead of 18.5.